In this video, we're going to talk about how we can do calculations to create new variables and plot them up. In most of our previous work, we've been able to use variables that are available within our model gridded output files, for example, from the GFS. However, there are times when we want to be able to calculate new variables because they may be important meteorological variables that just don't happen to be a part of the raw model output files. And so we're going to begin today by going through the handout associated with this series of videos called Calculating New Variables Using Python. To begin, we're going to start with some simple grid calculations that will allow us to see how we can do some basic math to create some of these new variables. And so to do so, we're going to go ahead and start with a former file that we've used. We're going to go ahead and use the gridded model output file. And so we're going to go ahead and duplicate this file. And then we're going to put that copy into our working notebook. And then we're going to go ahead and rename this file to be something like first calculation Python. And then we're going to go ahead and open it up. And now because I've used this particular notebook before, my setting is currently, for my kernel, is currently set correctly at Valpo Spring 2020. If you need to change the kernel, simply click on that upper right hand corner rather, and select Conda ENV Valpo Spring 2020. Now we could go ahead and run through this script to make sure that it actually runs, or this notebook. And we should get some data of 500 hectopascal geopotential heights. This is great stuff. But what if we wanted to, say, plot temperature in Celsius? We know that we can check our temperature underscore isobaric variable using tab completion here to find all the variables that start with temperature is going to have units of K or Kelvin. Now we know that it's a pretty simple difference between Kelvin and Celsius. And on page 1 of the handout, we see the equation. The temperature in Celsius equals the temperature in Kelvin minus 273.15. So the question becomes, how can we do this within our Python framework and add it to this dataset DS? This ends up being a relatively easy calculation, but currently we are using data that has a lot of forecast times. It turns out there are 129 forecast times for 34 vertical levels with 61 latitude and 96 longitude points. This is a lot of data. And so if we were to do our calculation on all of this data, basically what would be happening in the background is all of this data would be downloaded into memory locally. In order to avoid this, we want a subset for our time. And so we've already kind of subset for the date here in general, but that sometimes the date of our model initialization time is not the date of the forecast hour that we desire to plot. So what we're going to do is we're going to go ahead and take this little piece from our cell below, our plot underscore time variable, excise that with Control X, and then we're going to go ahead and add it to this upper cell, Control V. And what we're going to do is we're going to isolate this temperature variable. We're going to call it TMPK. TMPK is going to equal this ds.temperature underscore isobaric, and then we're going to use some metpy work to then select only a portion of our time, and we're going to set this equal to plot underscore time. We're going to go ahead and run this to make sure this does in fact work. And sure enough it does. We don't get an error. And so we can see then what this new variable looks like by typing tmpk. And we see that we have now subset our data array to be only one time, such that that goes away. And so now we have only our 34 levels and 61 latitudes and 96 longitudes. So now we're ready to go and calculate our new variable. And so as it says here on page 1 of the handout, to add a new variable to our dataset ds, we can simply give a new variable name within quote marks. So ds square bracket tmpc equals, and then we know we want to take our temperature variables tmpk and subtract off 273.15. If we go ahead and run that cell, it's going to take just a little bit to run, but then it does complete. And then we can see what our TMPC variable looks like. It is still a data array, and those definitely look like Celsius temperatures since we have negative values, and we've got some coordinates associated with it. Okay, so that's great. I'm going to minimize this output here, and then let's go ahead and set up and actually plot our temperatures. And we can do this in one of two ways. Let's go ahead and actually create just a second variable to plot. And so here we're going to change this to contour 2, and so we're going to have to change all of our little values here. Then instead of plotting geopotential height underscore isobaric, we want to plot TMPC. We're going to change our level to be 850 instead. And then we need to change the number of contours, or the contour interval that we're going to do. And so for temperatures in Celsius, we can start with -40 to 40 by 5 and see what that gets us. Now with this range feature, I'm going to actually want to make this 41 so I actually get 40 plotted. Now on the map for March, we're probably not going to see a 40, but that would help us in the future. In order to plot this, then we need to actually add CNTR2 into our panel. And let's go ahead and run this. We're likely going to get an error. Sure enough, we got an error. And the error reads, time attribute is not available. So it turns out when we subset here for our temperature, we subset for time. But we were still trying to subset for time by giving it a plot time. To overcome this error, we just need to change this value to none. Doing so allows us to then get our two sets of contours. But now we have two sets of black solid contours, which are not all that helpful. So we can add a few other attributes by setting line colors equal to red. Or rather, line color equal to red. So there we have our temperatures now in red, which is great. But we still like them. It's a little too hard to read. So contour 2 dot line style equals dashed. And there we go. We've now got 850 millibar heights, which we really should plot at 30. Go ahead and change that. And then our temperature in Celsius in red dashed lines. Now it turns out we don't actually have to do this whenever we want temperature in Celsius. Our MetPy system has baked in the ability to automatically do some temperature conversions like this. And so we just need to call temperature underscore isobaric. And again here, since we're drawing directly from our data set that we did not subset, we need to do plot underscore time. And we're likely not going to see anything because we're still in Kelvin. And that's because what we need to add is contour 2 dot plot underscore units equals deg C. And that will change it to degrees Celsius. And lo and behold, there we go. And we get the same output either way. So that's just a little bit into doing some simple calculations and being able to save it into a new variable within our data set. In a future video, we're going to talk about how we can do thickness and vorticity scaling parameters so that we can see those nicely in our plots. Thanks for watching.